I spent this year trying to make my own browser and I thought, why not make a video about it? What do Spotify, Steam, OBS and my browser have in common? That's right, the thing called Chromium Embedded Framework, or simply XEF. I want to show you how to embed a browser into a 3D app using this framework. But before we get into any 3D stuff, let's make XEF do something for us. I'm gonna use Struts for this project, so we will need bindings, and this crate works perfectly for what we need. Let's add it to our dependencies and set up a couple of environment variables. The first one is workspace, the root directory of the project, and the second one is the path to XEF binaries. Now we need to get the binaries themselves. Luckily they are attached to the crate, so we can easily download them and put them into the folder we set up earlier. Okay, we are ready to write some code. The first step is XEF initialization. This part is pretty straightforward, no special settings or anything to worry about. Next, we need to check if the current program is a XEF subprocess. Actually, this line of code says a lot. It basically defines the XEF architecture. In XEF, there is a main process called the browser process. This is our current program. But it's not the only one. XEF spawns additional processes and by default they all use the same executable. That's why we need to check with them. What's even more interesting is that every web page in XEF has its own extra process called the render process. It doesn't just handle rendering, it's also responsible for all the JavaScript code on the page. So the number of processes isn't constant at all and can get enormous. Next up, we have XEF launching, and right after that comes the most interesting part, creating a browser. I want to open the Google page. What do we need for this? First, the address, then the default browser settings, the settings for a window, and also some mysterious client. We will see what this client does a bit later, but for now let's leave it empty. Now it's time to call the createBrowser function, and right after that we run the main loop. Okay, let's build it. And of course we get a bunch of errors. It looks like we are missing some native window libraries, but don't worry. This issue can be easily fixed by adding the vnet crate to our dependencies, and it will also come in handy for our 3D stuff later. Build it again, and now everything works as expected. Perfect. Before running the executable, let's place all the XEF binaries next to it, otherwise it won't run. And when we launch it, we get the default Chrome window. We can open tabs, search for stuff, watch YouTube. Cool, but it's not exactly what we need. Time to fix that. First, we need our own window. We can use the vnet example here, but there is a problem. As we already know, XEF has its own main loop, and like any other main loop, it blocks the main thread, and the Windows event loop does the same thing. So we have to run them on different threads somehow. Luckily, XEF makes it easy with a single settings parameter. Just set it to true and we don't need the built-in main loop anymore. And this thing too. As for the 3D render part, I'm gonna skip it because it's simple and there are a lot of tutorials on the internet, but I'll tell you what I've done quickly. First, I made a shiny triangle, the classic first step for any 3D graphics developer. After that, I added some transforms and textures, then I set up an FPS camera and raycasting so I can pick objects, and I think that's enough for what we need. These rectangles will act as screens for our future web pages. It's time to embed some browsers. Let's write a handy function to create them, call it, and now we have two windows. That's not what we want. We need XEF to render web pages in the background and give them to us. And there is an option specifically for that. But when we launch it, we get an error. XEF asks us to provide the render handler. This is where we finally get to the essence of XEF, the handlers. These things let you get almost all sorts of information about the web page. For example, the display handler can tell us the page's title, address, console logs, and much more. If you want to know when the page is loading, for example, you can use the load handler. Need to handle downloads? The download handler at your service. And of course, if you want an image of the page, you will use the render handler. XEF actually has a lot more, but for our purposes we will use only the render handler. We need to create a structure to store the web page's frame data and implement the render handler callbacks for it. We will use only two methods. The first one helps Ceph to figure out the page's size. Here we need to return the view rectangle with the page's width and height, which by the way should also be stored in our structure. The second one is the actual painting. Ceph sends us the page's frame buffer and we just save it. Easy. Now we must provide this implementation to Ceph, and this is where the client finally comes into play. We implement the getRenderHandler function and return the required handler here. Now a couple of final steps to bring it all together, and here we are. The Google page in 3D. And by the way, not only Google. Alright, looks good, but there is still one thing missing. Mouse interactions. To make it work, we need access to that Ceph browser instance, because it's the only way to send mouse events. The obvious way would be return it from here, but wait, createBrowser function doesn't return anything like that. So what do? The answer is the handlers, again. Remember I said we would need only one handler? Yeah, that was not true. There's actually another one, the lifespan handler. It has some super useful methods like onAfterCreated, the perfect place to get a reference to our newly created browser. So again, we create a structure, store a channel to send the browser reference back, and implement the lifespan handler callbacks with the required method. Inside this method we put a reference into the channel, and that's it. Then in the client, we add a function called getLifespanHandler, and in our utility function we wait for the reference using the channel. Now we have the browser instance and we can call its methods to send click events and scroll events. And this is how it works. And on that note, I think it's time to finish this video. All the code is available at the link in the description. If you enjoyed this video, please like and subscribe. Thank you for watching.